Since functions come in multivariables in real-life situations, taking derivatives would have to be done partially. Learn about partial derivatives here in differential calculus. In the function y is equal to the square of x, we can say that the function of x is x squared. In the next function, having z is equal to x squared plus y cubed, we can denote the function as the function of x and y, and the derivatives are done partially, one with respect to x and the other is with respect to y. Partial derivatives focus on a single independent variable, and all others are considered as constants. Say we have the equation z is equal to x squared plus y cubed. We can take the partial derivative of z with respect to x and also the partial derivative of z with respect to y, where d is used for ordinary derivatives and the squiggly d for partial derivatives is called del. Some examples are presented to show the procedure of first-order partial derivatives. The equation is z is equal to 3x raised to 4 plus 6 root of y less 5. For this example, we are to take all the first-order derivatives of the function, starting with its partial derivative with respect to x. Take a closer look at the last term. It includes the partial derivative of a constant, which is considered 0 based on the rule of derivatives. The next term to focus on is the second term because it has 6y raised to 1/2, and we need to take its derivative with respect to x. The term is taken as a constant as they have different variables. Thus, this is also taken as 0. So the reduced function becomes the partial derivative of z with respect to x as 3 times the partial derivative of x raised to 4 with respect to x plus 0 minus 0. As we take this a step at a time, we simplify it as the constant 3 times 4x cubed using power rule. Then we multiply the derivative of x with respect to x, which is taken as 1. So the partial derivative of z with respect to x is 12x cubed. Next is to take the derivative of the function with respect to the other variable y. Just the same, the last term will be simplified as 0, and also the first term is considered as constant, since it is with an x variable and we are solving for the derivative with respect to y. The shorter form of the function is 0 plus 6 times the partial derivative of y raised to 1/2 with respect to y minus 0. Again, with the power rule, we get 6 multiplied by the derivative, which is 1/2 of y raised to negative 1/2 times the derivative of y with respect to y, which is considered 1. So the partial derivative of z with respect to y turns out as 3 over the root of y. For the function w is equal to x squared y minus 5y squared z cubed plus 4x plus 12y minus 7 tangent of 4y, we have three variables x, y, and z, which means there are three first-order partial derivatives. Let's start taking the partial derivative of w with respect to x. Focusing on x, the second, fourth, and fifth terms are considered as pure constants, so their derivatives are 0. The third term includes 4 times the partial derivative of x with respect to x, which can be taken as 1. So the reduced derivative turns out as the constant y times the derivative of x squared plus 4. The derivative of x squared is 2x times the derivative of x with respect to x, that is 1. So the partial derivative of w with respect to x is 2xy plus 4. Next is to find the function's partial derivative with respect to y. Since most of the terms have the variable y in them, the only term considered as pure constant is the third term with 4x. Next is to simplify the fourth term with 12 times the derivative of y with respect to y, which is taken as 1. The partial derivative is then transformed into the constant x squared times the derivative of y with respect to y minus the constant 5z cubed times the derivative of y squared with respect to y plus 0 plus 12 minus 7 times the derivative of tangent, that is secant squared of 4y times the derivative of 4y with respect to y. dy all over dy is 1, and d of 4y over dy is 4, making the whole derivative as x squared minus 5z cubed times 2y times derivative of y with respect to y plus 12 minus 28 times secant squared of 4y. Again, dy over dy is 1, so the final derivative of w with respect to y is x squared minus 10yz cubed plus 12 minus 28 times secant squared of 4y. The last partial derivative for the function is with respect to z. Seeing that most terms lack z, the only valid term for the function is the second with negative 5 times the partial derivative of y squared times z cubed. So the reduced derivative becomes 0 minus 5y squared times 3z squared times the derivative of z with respect to z plus 0 and another 0 minus 0. dz over dz is 1. So the partial derivative of w with respect to z is negative 15y squared z squared. Example 3 has z equal to sine of 4 over x times e raised to x squared y minus 4 times y cubed. The function has two variables x and y, so we take the partial derivative of z with respect to x first. The main function has two terms multiplied together, so we take its derivative using product rule. So the derivative turns out as sine of 4 over x times the derivative of e raised to x squared times y minus 4y cubed, plus the second term e raised to x squared y minus 4y cubed times the derivative of sine of 4 over x. This can be further solved as sine of 4 over x times e raised to x squared y minus 4y cubed times the derivative of the exponent x squared y minus 4y cubed plus the second term with e raised to x squared y minus 4y cubed times cosine of 4 over x as the derivative of sine times the derivative of 4 over x. Solve this further by distributing the derivative into the two terms x squared y and 4y cubed. Then transform 4 over x in the second term as 4 times x raised to negative 1. At this point, 4 derivative of y cubed is taken as 0, as we are taking the derivative with respect to x. Reduce the long derivative by simplifying the first term with 2xy times dx over dx, and the second term includes 4 times negative 1 times x raised to negative 2 with dx over dx. And again, dx over dx is 1. So the simplified partial derivative of z with respect to x is 2xy times e raised to x squared y minus 4y cubed multiplied by the sine of 4 over x minus the ratio of 4 times e raised to x squared y minus 4y cubed times cosine of 4 over x with x squared. Now let's take the partial derivative of the function with respect to y. The first step follows the same pattern as what was solved previously. But since the derivative in the second term has only x, but we focus on y, we take this as constant, making the whole second term as 0. Next is to distribute the derivative of the first term between x squared y and negative 4y cubed, where the form turns into x squared minus 4 times 3y squared times the derivative of y with respect to y, again taken as 1. So the partial derivative of z with respect to y is sine of 4 over x times e raised to x squared y minus 4y cubed multiplied by x squared minus 12y squared.